HanselMinutes.com. It's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 358, recorded live Thursday, February 7th, 2013. Support for Hansel Minutes is provided by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, training developers to work smarter. And now offering GesturePack, a powerful gesture recording and recognition system for Microsoft Connect for Windows developers. Details at gesturepak.com. In this episode, Scott talks to 343 Studios engineer Caitie McCaffrey about how they use the cloud to run services for Halo 4.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and it's Halo Week. I just made that up, but it would be cool if it was Halo Week. But I do have on the phone Caitie McCaffrey from Microsoft, who also works for the internal studio 343 Industries. How are you, Caitie?
I'm good. How are you?
Very cool. Very cool. I met you at the nerd dinner that we had a couple of weeks ago at the mall, which was very exciting. Yeah,
that was cool.
And you were up there with my buddy Hoop, and you guys work on the back end of Halo. Is that right?
Yep. We work on all the services that power all the experiences and the Halo games.
Okay. So I'm looking at, I've got Halo Reach, I've got Halo 3, Halo 4, I've got Halo Anniversary Edition I just got.
Yep.
All of those have back-end services?
Yep, they all have back-end services, and in addition, we power Halo Waypoint and all the mobile experiences, the Xbox client, things like that. Okay, so I'm kind of ignorant to this. I know that when I do multiplayer, it's keeping track of my profile and my really, really low rank, and my horrible scores. And I assume that it's also sending real-time information about where I am and what direction I'm looking and stuff like that. But what are the services that Halo needs to operate? Sure. So we have a bunch of different services that we're currently that are evolving over time. We have the stats service, which records all of your stats data, so like your headshots, your kills, like who killed who with what weapon. That all gets sent up to us, and we keep track of that and make it available on our Waypoint clients, and also some of that data is available in game. We have a presence service, so when you are playing Halo Online, you are telling us periodically what you're doing, and we make this information available on some of our Waypoint clients, but mostly in game. You see this in the active roster on Halo. This is actually a different service than most Xbox Live titles use. It's a little more robust. We update more frequently and send more data. We also have a title files service. So this is where you get all your hopper files, so your different playlists, which tells you what maps and modes you can play. In Halo 4, this is how we deliver like some of the Spartan Ops playlists.
Okay, so slow down, because you work on Halo all the time, and I play it like twice a year. So title files, that's like when I go in and I say I want to play Deathmatch, or I want to play whatever with the skulls, and those graphics that come down?
Yeah, so it's basically just a list of different maps and modes that you can play and matchmake into. So we update those weekly right now in Halo 4. So like we didn't originally launch with SWAT, I believe, which is just a game type in the Halo universe. And so a couple weeks later, we then made a SWAT playlist because people wanted to play SWAT as well. So it's just, and so when we release new map packs, we'll also release new playlists, because that will make the new maps that just came out available for people who want to play on them.
And these things like stats and presence, there's like the real-time multiplayer aspect of services, but then stats like, how many times you've shot someone with a shotgun. Right. Are those things being calculated on the server or on the client?
So some of it's a mix. We get some aggregates from the client for what you did in the game, but your lifetime of like kills and deaths and all of that is being aggregated on the server. It's also kind of interesting to point out that our stats service is not real time. So you play a game and then we get your stats, and we may be able to process it right away, but we also have the ability to wait if we're having a lot of load. Presence, on the other hand, is completely real time. So everything you're seeing there is up to date and happening right now.
That's really interesting because I was talking to the Stack Overflow guys before, and you know how Stack Overflow has achievements, and
Right.
some of the achievements are super complicated. You know, it's just like, I don't know, got downvoted on a Tuesday by a guy from Russia. And it's like, whoa, how did they do that? And they said that they've got these triggers where, something gets set up and then they'll fire off a trigger, and that's kind of real time. But then they've got batches that'll run. Some might be every hour and some might be once a week, depending on the complexity of the calculation of the achievement. Is your system similar?
It's not like we're running batch jobs on SQL is sort of the analogy you're making there. What we do in Stat Service is we use Service Bus, Azure Service Bus queues that we get them from the game. We get your data, and then we send back, as soon as we've stored it durably, we send back okay, we got your data, or response to the game, and then the players can keep playing without having to wait for us to do a more complex operation. Once we do start processing your stats, though, we process and update everything at once. So it's just a transaction.
Oh, okay. So you're using. So the interesting part there is you're using Azure and you're using Azure Service Bus. So you're kind of using it in a queuing sense. You throw it into the queue, fire and forget, so it doesn't slow down the game.
Exactly.
And then the server gets around to it, and if the queue gets full, well then you'll get to it when you get to it.
Exactly.
Okay, that's cool. So stats, presence, title files.
We have a couple more. We have a user-generated content service. This is whenever you take a screenshot or you make a map in the world editor called Forge. You can upload these things to our service, and then they're available via Waypoint, or other players can download them as well. So we have a service for that. And then we also have a cheating and banning service, which if you are doing bad things in the game, from quitting or griefing other players or being obnoxious on your microphone, we detect all of these things, and then we can actually automatically ban you in real time, semi-real time, and keep the sort of the integrity of the Halo matchmaking experience good for most players.
Wow, you can really tell if I'm being mean?
Yeah, so we look at a bunch of different things, like are players muting you? Are a lot of people disconnecting from games when you're the host? We have a lot of different metrics that we use to run and determine what we should ban people. And we have a bunch of flexibility in our system, from we can ban you for a day if we think like maybe you aren't being really mean, or like doing it inadvertently, or if you keep doing it, we can ban you for longer. And this was a system that was also in Halo Reach, and I believe 3 as well.
Wow, okay. So you're not like listening to my conversation and like, oh, he said a naughty word. You're looking at how people react to me.
Yep. We're using a lot of the user-generated data that's sent up to us.
That's cool. This sounds like a lot of compute work.
Yeah, so cheating and banning is really interesting. It's one of the services that I wrote and I really enjoyed, because it used to be done on a nightly batch basis, sort of like the Stack Overflow achievements. We went and used a complex event processing system to do that, so we can do it in more real time. And so things are happening. You get generally when the system's up and running, you'll get the feedback and get banned within 10 to 15 minutes of us detecting that you've done a number of undesirable things, whereas in previous games you would get banned, the next day.
Wow. Okay. And you wrote that. So I show up and let's say that I join games and I start being a jerk, and then people start leaving and I'm the only guy left. And this happens a couple times. These are basically stats. These are events that are throwing into a big pile, but they're not correlated events. They're just that, gosh, when Scott shows up, people run away, and they're sitting in a queue somewhere.
Yeah, so without getting too much into the depths of the system, it's basically like an event-driven architecture where we look at all the events that are coming up from the players over a period of time, and then we're processing and aggregating a bunch of different events based on rules that we've decided that our community management team has decided if these things are happening, this player is probably not playing is not being a good Halo player, right? They're probably doing something wrong.
Sure. I'm less interested in the details. Like, I don't want to give the griefers like data, but I'm interested in like you. So you wrote, and this runs in Azure, and you wrote this in C#?
Yep, it runs in Azure. We used a combination of this couples with our stat service. that gets all the events from the game. And we also used Stream Insight in Azure.
Mm-hmm. When you write something like this that is big scale, giant scale, how do you keep when you're working this? How do you keep from asking for too much data? Like you're asking questions of a backend system that could explode. It could get like combinatorics or order, n+1 type questions where it's like, oh man, I didn't realize that I just brought the entire system to its knees because I asked a question that I thought was reasonable, but it turned out to be a terabyte of data.
So there's two, actually, we have a BI system as well that I haven't mentioned that's, running Hadoop and also in Azure. And that's interesting because that's sort of, we have our data in a different store. So that's sort of how we prevent like taking down the stat service when we're running a really long a long query that pulls a lot of data. For cheating and banning, the interesting thing with complex event processing is the model is sort of like a normal thing is you have all the data and then you run queries over it. With complex event processing, you define the query and then you run a bunch of data through the query. And so the data needs to be temporal in nature, but you're not going to have this problem where you're trying to pull a bunch of data and then hitting your servers really hard. We're just consuming a feed of data from the game and then, creating higher level events on top of it and then acting on those.
I see. So it's like a sieve that you're pouring this kind of fire hose of data through and you're kind of seeing if the cheaters fall out of that, as opposed to throwing a bunch of data in a pile and then shoving your hands through it and looking for this cheater in the haystack.
Yes. So it's sort of a different way of processing large amounts of data.
That's cool. Okay. So stats, presence, title files, user-generated content, cheating and banning. That sounds super interesting. When I log in, I'm talking to Xbox Live. That's not part of Halo.
Exactly. So Xbox Live provides a set of standard services that allows the game to find our servers as well and talk to our services. It also provides things like when the matchmaking that is running is actually running through Xbox Live, achievements run through Xbox Live, things like that.
And do you how do you deploy this stuff? Like, do you have like staging where like people who are working on this are playing either a version of Halo or they've pointed that version of Halo at the staging server, and then you can simulate a bunch of bad guys being bad without being on the live network, and then you roll it over into production later?
So we use the Azure portal to do a lot of our deployments, and we also use this cool tool called Cerebrata. They have this thing called the Cloud Storage Studio and Azure Management Studio that it looks like the portal, but it has a lot of nice UI features on top of it that makes deploying builds, editing config, doing a VIP swap type of thing in Azure really simple. Right now, we deploy to staging and then do a VIP swap to change out our builds in production.
What is a VIP swap?
Oh, so in Azure, for every sort of subscription ID, you have the production deployment, which is what is available via your nice friendly DNS name, and then you have a staging deployment, which is only accessible via a GUID, and isn't what the Azure load balancer is sending work to. And so what we do is we spin up actually two full deployments at once in staging, and then a VIP swap is when you tell Azure to change what's in staging with what's in production. So it just does an atomic swap.
Is VIP like VIP, like virtual IP?
Yeah.
Okay, so you don't really like when I was used to doing staging to production roles in the pre-cloud days, there were a bunch of machines that I could point at and say, look, those are staging, and then these are over here in production. And they were very different. And we wouldn't typically swap. It would usually be a roll forward thing. And you don't usually get into swapping comfortably between two systems and calling them both production until you're a very mature organization. But it sounds like with the cloud, you don't really care, right? I mean, they literally production and staging can be the same thing because you are going to just swap back and forth.
Exactly. It's a very different deployment model, and it's also very interesting when you think about designing your services on top of this, because you have to basically be super fault tolerant because we're taking down the production service and there may be data in it and we want that data to replay, right? We don't want to lose any data. But at the same time, we don't want to have to we don't expertly time when we do our deployments. We can do them at any time and it just sort of works. And so there's a lot of things from, like idempotency to being super fault tolerant that are helpful in doing that.
When we would have people on like a shopping cart in the apps that I worked on, we would start to kind of slowly drain them off. So we would slowly bring one production site down and slowly bring the other one back up. Mm-hmm. Is that similar kind of thing, or are you literally swapping the entire thing out from underneath them, and the queues keep it from feeling like something's happened?
Yep, exactly. We just swap them in and out. We don't really do any drain off right now.
Wow. Will you do that like on a random Tuesday afternoon, or do you wait until like the middle of the night? Because someone's always playing Halo somewhere.
Exactly. Yeah. So we do deployments. We try to do like really impactful ones at night. We don't get up at like 2 a.m. and do deployments. We do them generally during the day when we're here. Mm-hmm. And then launch week was its own special thing, because I guess it's notable in game services. You have this very different load pattern where on launch night or launch week, in the first couple of weeks, you see your highest number of concurrent users, and then it sort of tapers off and becomes more stable. Whereas most services, you sort of have like this gradual ramp up to your peak number of users. So to sort of help with this, on launch week, we had at least 5 people in the office around the clock. We were working like 8 to 9 hour shifts, and then, addressing issues and monitoring when they came up. And so that week we were just like fixing things and switching in things like, at least once or twice a day.
Does it feel like helpless in that you're using this cloud service that you didn't make? Like, you made what sits on top of it, but you didn't make Azure. So like from the perspective of you guys, the Halo team, that, there's this company out there called Azure. I mean, we happen to be Microsoft, but,
right.
It's a thing you didn't make, so you can't control it. And I always thought about that, like Netflix uses Amazon, and like if Amazon's mm-hmm. down or if something happens, the Netflix guys are like, what do they do? Just call a 1-800 number? Or how do you freak out when you can't like go and reboot the server yourself?
So there is the Azure support team as well, and then because of our scale and size, we had some help from the Azure team and people that we could call directly if that happened. I mean, but in any system, there's sort of like, right, you don't really even own your machines. They're in a data center somewhere, mm-hmm. and you have people who could go and like, kick out a power cord and like, obviously this doesn't happen all the time, but there are issues there as well, whereas like a drive will just fail, and like I can't control that either. So Azure's just a different set of problems, and it helps that we basically rebuilt the service stack from the ground up to be on top of Azure. So we sort of address those issues, like, right, we know from the beginning that they can pull any VM out from under us and restart it. So we went and built the system with that in mind.
That's interesting. So there are people who might move an existing system over, and I think there's a lot of discussion mm-hmm. around migration and moving this website or that website. And then there's also concerns about vendor portability. There are those who are always paranoid about that, so they'll build their system based entirely on VMs. But mm-hmm. I'm hearing you say that you looked at the things that Azure offers, like compute and storage and Service Bus, particularly Service Bus, mm-hmm. and built it to sit on Azure and to use the Azure stuff. And it doesn't have an identity that is not attached to cloud services.
Exactly, right. So this is the first, I guess it's interesting to point out, this is the first game that is built entirely, or Halo game that is built entirely on top of Azure. Our backends before used to be in physical data centers. And so we took, our team took on the challenge of rebuilding and porting it to Azure, because for a number of reasons, with the load pattern, it makes a lot of sense because you can start turning things off as you don't need them. You don't have to buy all this really expensive hardware that then goes out of warranty. Right, we get the nice elastic scale. And so that was really worthwhile to us as a service, and we wanted to do that. And it makes a lot of sense for future experiences and maintainability of the service. And so we just rebuilt everything on top of Azure, and we re-architected and looked at every service, even though a lot of them are the same as have the same names and have the same functionality of what was in previous Halo games. Mm-hmm. But we went and built it for Azure specifically.
Were there discussions where you had to say, well, do we know if Azure is big enough for Halo? Like, I don't know if you're the biggest client, but I'm just saying, like, there must have been whenever you're evaluating a cloud service, you're like, is this going to be big enough? Because we don't know how popular Halo 4 could have been. It could have been bigger than Azure, maybe.
Right. So we definitely had a lot of conversations and worked with the Azure team to make sure, right, that we could get the number of cores that we needed, that they were scaling out, and so that was right great. I mean, I think we talked with Clemens from Service Bus, and during one of our perf tests, we actually took production Service Bus queues down, and so but they worked with us to make sure to fix the problem and make sure that they were ready for launch.
That's pretty cool. I had this conversation with a guy from Netflix. He was explaining how they were his cloud service provider was going from spinning Rust hard drives over to SSDs, and this guy in the audience calls out, "Well, SSDs fail, and what about this and that, and performance and trim and da 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 da." And the guy from Netflix was like, "Well, that's not my problem. Like, I'm renting them."
Exactly.
And I was like, whoa, that just totally blew my mind. Like, oh my goodness, he's so enlightened. I'm renting them. Like, yeah, drives fail, but it's not my problem. Like for someone like Netflix, where a popular movie comes out, or someone like Halo 4 comes out, I'm going to rent a bunch of hard drives. And when I'm done and the game becomes less popular and Halo 4+1 comes out, then I'll just rent some more. So like all those machines you had in data centers, like before, you don't need those data centers.
Exactly. Well, so we still do support like all of the old games. We haven't migrated to Azure. So we still own some physical machines and some data centers, but it's really nice for entertainment when you sort of look at the way that those the users sort of like flock to one hot thing of the moment, and then it drops off. But you can still support the long tail of the entertainment experience in the product, because you don't have to maintain all these really expensive machines. You just keep up the number of cores you need running. And it is really nice. I kind of really enjoy like not getting woken up in the middle of the night because, the SQL drive failed, right? Azure just deals with it and spins up a new instance of a node that went down for me, and I don't even get notified.
Yeah, exactly. And also, I think as a user of games, I always hate when a game that I really dig, I get a notification that like, oh yeah, the backend service for this game is going away now because we can't afford it. It's like if you're on like Halo 15 and I'm still playing Halo 4, you could go and run it on a machine and it's going to cost you guys $5 a month and it doesn't really matter, right? You could keep it running forever as far as you're concerned.
Exactly. So, and that's one of the other nice things about this, right, is like we want our users to have a really great experience and we want them to play what they love. And so this makes it really easy to do that. And it makes it really easy to keep around all this data and whatnot. Like, I don't care. It's just out there and it's durable, and Azure takes care of a lot of the operating systems and the software upgrades for me.
There is one framework that you're using that I had not been familiar with that's called Orleans, like New Orleans. What is Orleans?
So Orleans is a Microsoft research project, and it's basically a framework for building large, reliable, distributed systems, and it's based on the actor model. And so we partnered with them really early on and thought this was a really cool thing and would help us build and write the code much easier. And so we've been working tightly with that group as well.
And I'm looking at this here. They have this thing called grains. What is a grain?
A grain is sort of a logical unit used to process data, and all of anything that goes, any of the calls that are in a grain run single-threadedly. So everything is asynchronous and non-blocking, but it abstracts away the idea of me having to worry about threading within a single grain. So I can write code synchronously, basically, in a grain.
I see. So writing code that is synchronously, of course, is easier because you want to write code that focuses on business.
Right.
And if you're writing code and you're sitting on a thread and you need data and from all sorts of different locations, you can get your business code kind of tangled up with the business of threading.
Mm-hmm. Yeah. So this simplifies a lot of the threading problems. It also is nice because it scales out and does a lot of the addressing for us. So when I say, like go post stats to, for Scott, it just goes, I like do the lookup to find where in this, Orleans does the lookup for me, like where to go send this, what machine to go send this message to.
Wow. I'm looking up here and there's no downloads. There's nothing. It's from the Extreme Computing Group, which is an awesome name if you're going to work for a group.
Yeah, so unfortunately this isn't available publicly on Microsoft or for people outside of Microsoft to use. Mm-hmm. But working with them is like, we worked very closely with that team and they're really awesome. And it's been, I thought it was a great experience working with it and made our lives a lot easier building on top of their framework.
Wow. Hopefully that'll come out, or I'll hear more about that. That sounds actually pretty sweet.
Yeah, it's very cool.
That's cool. And Service Bus, I wrote a couple of basic service relays and some different stuff, but I haven't dug too much into service. And I do know that, like you said, Clemens Vasters from that team is always telling me to get on Service Bus. And there's actually a video where you're up there with Hoop and one of your teammates, Angus,
Yep.
talking about Service Bus on Channel 9, and I'll put a link to that in the show notes. How is Service Bus different from just using like MSMQ?
So I'm not super familiar with MSMQ, like looking into that, but we chose to use that because it gives us the ability to scale out really easily, because we wanted to be, the main goal there is we wanted to be able to have the server go down just in case it did for whatever reason for, I think 2 to 3 days, and we don't lose any data. So we use Service Bus to build in the reliability of the stats system and the scale, because when on lunch night, we get a ton of users coming in playing, and perhaps we had issues with stats, or we just couldn't process as many games as quickly as they were coming in. Service Bus gave us the ability to sort of queue that data, store it durably, and then process it as we had time, so we didn't just slam our servers.
And Service Bus is a service on Azure that you're abstracting away what's underneath it. Like, you don't have to think about if there's VMs underneath the Service Bus, right? If you want more service buses, you just dial it up?
Right. So you just basically say, I want this many queues, and that gives you a set amount of data that you can use, and then you throw things into the queue, and then you can pull them out, and once they're in, they're stored durably, right? And so you don't have to worry about anything going down or getting lost. And it's pretty simple, right? You just push things on and pull them off, and it's there for you. So it's a really nice solution for building out the scale out. And
does this thing automatically scale? Like, you're looking at your database, you're looking at your message sender, you're looking at the receiver of the messages. These things are kind of ebbing and flowing as traffic comes and goes.
Right. So it's not elastic in the sense that they don't automatically spin up queues as the traffic wanes and fluxes, right? We have a set number that we use, and it's also the same way for all of our compute and storage instances. We basically planned for amount of load, and then as we go through, when we do deployments, we'll actually take down the number of cores we're using and make that decision. We don't have anything built in right now to do that elastically and just determine that for us.
And do you use queues, Service Bus queues, and Service Bus as a relay?
What do you mean by as a relay?
There's Service Bus relay service.
Oh, okay.
And there's Service Bus queue.
I believe we just use Service Bus queues right now.
Okay. Cool. And what do you do for logging? Like, if you have to go and debug all of this, what's your log? I hope you don't have text files.
No. So we have an ETW, event tracing for Windows logging system in place.
ETW?
Yep.
What is that?
So so it's basically it's a new product of .NET 4.5. It's sort of a model for sending events and tracking stuff like that. And because right now when you go to Azure, you can write to the WAD logs, which is the diagnostic table, but the number of logs that we actually wanted to write didn't scale.
Right.
So ETW was this framework that we basically built on top of that allows us to sort of ship the logs out and not have to store as much. You don't store all the strings, right? You sort of store the format once and then apply, when you're looking at the logs, it applies it for you. You just store all the parameters or all the variables that you're popping in and out. And then we also use MDS, which is an internal Microsoft tool right now to view the logs and whatnot.
So ETW, for folks who are wondering, means event tracing for Windows, and it's a kernel mode logging feature, like you said.
Yeah.
But this is something that was added in Windows Server 2008, and it's basically integrated into the kernel such that you could turn it on and off as you're going, and it's very, very low overhead.
Yep.
Yeah, it's pretty nice, because if you have a user mode application, but you want to get some really low level debugging, including things like even device drivers. You can go all the way down to the bottom if you want to. It started actually in Windows Server 2. It's Windows 2000, but it got really, really interesting in 2008 server when IIS and different websites started using it. Mm-hmm. Interesting. Okay, and so then you view that from a larger application, a larger viewer, a log viewer.
Right. That sort of aggregates all the logs from all our different machines and by our services, so we can run queries on top of them and look at what we think is interesting.
So I heard that you said that you used a management, the management portal as well as a third-party management portal. But do you ever do any scripting? Like I kind of imagined a large system like this would include PowerShell scripts to fire up and turn down things.
So we have some tools right now. It's one of the things that we're working on currently is building out stuff. So a lot of the things that we do manually through the portal and whatnot are done via just, one-click deployments type is the scenario that we want to get to. We're just not there yet because we just didn't have time.
Mm-hmm. And when you, when I log into Azure, I have like a live ID and a credit card. Is there like this is just a totally random question because I got to ask a random one at the end. Is there like some dude's credit card being charged?
I am actually not sure how our billing is set up. I know one of the funny things is we also used to be on like one developer account in Azure.
Yeah.
And because we were new to Azure, everyone wasn't shutting down their cores and their deployments every night because you just don't think about that coming from a traditional service background. And so they gave every developer, we now have our own accounts so that they can see who's costing them a lot of money.
Oh, that's awesome. Okay. Because that is the fear. I mean, that's funny. Once you have a whole lot of stuff running on Azure, you do have to think about does this need to be running? And and it's kind of cool. It's almost like running your website in Azure is almost like the way that you drive a Prius. If you've ever got you have a Prius, anything like that? Have you ever driven a hybrid car?
Yeah.
There's a gamification when you get a hybrid car, and it's like, okay, I can do 44 miles per gallon, right? I'm going to save 5 cents. And it changes the way you drive. And cloud services change the way you write code in that you want to squeeze that last penny.
Right. So it's just like an interesting note. Obviously I would never say just take code out of a server and port it into Azure. You could do it and it will probably work, but it's not going to be super cost effective or efficient. I think really thinking about how you design your service for Azure so that you're getting the most out of the pricing model and you're building it for this sort of it's kind of a chaotic environment where you assume things fail is super helpful and makes your services more reliable, and it'll make them scale out better as you move forward and get more users as well. Very
cool. Well, thanks so much for chatting with me today, Caitie.
No problem.
Cool. Next couple of weeks, we're actually going to have the Waypoint, the client-side people who consume and use your services, and we're going to talk to those folks too. So we're going to see how Halo works on the back and the front end.
Cool.
This has been another episode of Hansel Minutes, and we'll see you again next week.